are studying physics today that we didn't know we could study when we first built the facility.
We have a tool here that nobody else on the planet does, and this provides us sort of unfettered and exclusive access to states that just cannot be created any other way outside of a weapons test. Z is basically a giant battery. It's a big capacitor bank. The entire innards of Z is a series of stages meant to simply take that electrical pulse and compress it in space, compress it in time, and generate the most extreme pulse of electrical power that you can on this planet. And that energy is funneled down to a tiny little centimeter-sized target region at the very middle of the facility, and that's where the physics experiment is.
Well, for a very, very brief period of time, we actually have more power flowing through our machine than all of the rest of the world combined.
Z has probably on the order of 50 people that actively work every day on the machine. The center has about 300 physicists, theoreticians, managers, support staff. It takes a large group of people just to get a shot on Z.
The broader mission of the nuclear deterrence program in the United States is to steward the existing stockpile and to be prepared to change or modify that stockpile as external threats present themselves.
In the absence of more underground testing, to understand whether our aging weapon systems still behave the way they should is by simulating them. And those simulations rely on physics models that we have no means to test and refine and continue checking and improving without facilities like Z.
Much of what we know about the U.S. stockpile was learned in underground weapons tests. A lot of the history of pulse power is centered around the idea of making radiation sources in the laboratory that we could then use to apply in a much more controlled environment and get higher quality data for effects testing.
But we're trying to mimic states that are consistent with the states that you would see in a nuclear weapon.
You can't do stockpile stewardship without fundamental science because the entire enterprise is based on fundamental physics. These systems wouldn't work if we didn't understand the physics going into them.
Some fraction of the shots that we use on Z every year are to study the effects of things like X-rays on electronic components. The key reason that you want a science capability like Z around is to evaluate whether you can safely insert any of those new electronics into the stockpile.
I study the behavior of atoms in extreme environments. So when you squish something really hard, what happens to the atomic structure?
The pressure that we can create with the Z machine is about 100 million times atmospheric pressure. We can use that pressure to accelerate materials at very high velocities, anywhere from hundreds to 1,000 kilometers per second. We can create very high velocity implosions, grow material together, and reach even more extreme pressures than we could if we just slowly squeezed on them.
We can achieve temperatures hotter than the center of the sun. We can fuse hydrogen atoms together to create helium and produce copious amounts of energy.
About 10% of our shots on Z every year are devoted to our Z Fundamental Science program, where we collaborate with universities across the country who do very fundamental research on things like what are the properties of the matter at the center of Saturn.
The connection between the atomic scale physics of fusion energy, the stockpile stewardship, the radiation effects testing, even to fundamental science like astrophysics, these are all things that we can try to understand better using Z.
The whole point of this facility is to be able to ask and answer questions that our country needs to address as new threats evolve or as the science leads us to new places.
Charge complete, arming to fire.
We're still not done learning what we can do with pulse power. We're still learning how to use it every day.
We're continuously thinking of new ways to use this resource, and the nation is better because of it. Our stockpile is safer because of it.
Sometimes you have to push the boundaries of what's possible in order to achieve something that's truly revolutionary.